Hi everybody, welcome back. We are on 4.4, the quadratic formula, and we're going to do part 2, which is called the discriminant. So the discriminant is the underneath part of the square root, so the b squared minus 4ac that you see in your quadratic formula. So it's what's underneath the square root. So if you examine this expression, b squared minus 4ac in the quadratic formula, this allows us to determine the roots, and it allows us to determine what types of solutions we're going to have, and how many solutions we're going to have. So on the first one, as you can see here, I broke it up into there's three parts here. The first one is x squared minus 2x minus 3. I've graphed it here so you guys can create a little sketch on your page. It doesn't have to be perfect. It just needs a little sketch. And when I've graphed it, I used the Desmos program, and I've noticed that there's two real solutions. The solutions are x equal to -1 and x equal to 3. Those are two zeros, two roots. Okay. Now I'm going to use the quadratic formula, so I've graphed it as it mentioned, right? And now we're going to look at this quadratic formula, and you'll notice that when we plug the quadratic formula in, our value underneath the square root is 16, and that gives us two real solutions. Let's look at the second example. We have x squared minus 2x plus 1. Some of you may recognize that as a perfect square trinomial, and you would be correct. So this comes down and touches the graph at 1 and 0. So let's look at the quadratic formula, and let's look what's happening underneath the square root. So you'll notice, the square root is 0, and then ends up with one solution. And that's because, remember, you're plus or minusing the square root. So if there's nothing but plus or minus, it's 0. It's the same, so you only end up with one root. Because 2 plus 0 divided by 2 is 1, and 2 subtract 0 divided by 2 is 1. So that's interesting. So if underneath the square root is 0, you get 1. And then the last one we'll graph here is 2x squared minus 2x plus 3. So you'll notice I just changed the y-intercepts, which created some new things. And some of you are saying, well, I just did a few little transformations, and you'd be right. Talk about that a little later on. But you'll notice it doesn't come down, it doesn't touch the x-axis at all. And you'll notice when you plug it in the quadratic formula, which I've done here, you'll notice right here that we have -8, which is no solution. So we have a positive solution, 0 solution, and a negative solution. Positive yields 2 real solutions, 0 yields 1 real solution, and a negative if there's no solution, because you can't take the square root of a negative number, as you guys are aware. So this is called, what's underneath there, the b squared minus 4ac, this is called the discriminant. And here are the number of roots of a quadratic equation. And you guys knew there was 1, 2, and 3, but this is a quick way that we could determine, without graphing, just looking, doing quick mental math in our head. So if we have our discriminant, I know I said determinant, and I do say that sometimes it's matrix stuff. I do apologize. It's just something that slips up. The discriminant, not the determinant, discriminant, my apologies. The discriminant allows you to tell you how many real roots you have. We're going to talk a little bit about this a little later on. So there's two real roots when it's positive. So that's greater than 0 means it's positive, right? So if you get a number underneath the square root that's positive, that tells you there's two real solutions. If you get it equal to 0, that tells you there's one. I showed you why. And if you get less than 0, then this means there's no real roots. No real roots. All right. Let's explore this a little more. First thing what I want to do is I want you to, right here you'll notice in the second one, you guys on your sheet would have -6. So if we can switch that to -7, that'd be great. I caught that a little late. I do apologize because I wanted to show obviously the 3 scenarios. So in the first one, we have 16x squared plus 8x plus 1. It says use the discriminant to determine the number of roots for each. Use technology to check your answers graphically. So the first one here, we put it in. We have 8 squared minus 4 times 16 by 1, which is 64 minus 64, which is 0. So since b squared minus 4ac is equal to 0, there's only one real root. Let's confirm this using Desmos. So we'll plug in our function. So we take our graph, we plug in our quadratic, and sure enough, it comes down and touches the graph at one location. So yes, indeed, there is only one root. Let's look at the second example, example B. So we plug everything in. B is -7, negative square root is 49. Put in 4 times 3 times 3. A is 3. C is 3. 3 times 3 is 9 times 4 is 36. 49 subtract 36 is 13. So since b squared minus 4ac is greater than 0, there are 2 real roots. So when we graph this expression in our equation, it should say equals 0. My apologies. And again, we put y equals, right, in our equation, so that we have 3x squared minus, remember, change that 6 to a 7. It's on your sheet. 3. And of course, we have 2 real roots. And the last one, example C, it shows we have discriminant. Put it in, we get 7 squared minus 4 times -9, which would be -72. This would be positive 8 multiplied by -72. 49, subtract and use -43. And since b squared minus 4ac is less than 0, it's because it's negative, there are no real roots. So that means that it does not touch the x-axis when we put it in our Desmos program to confirm. So let's do it. So we have -2 plus, plus 7x minus 9. There's your graph somewhere. There it is. And there's your x-axis, and it doesn't cross, right? There's no x-intercepts, so that means there's no real roots. There you go. And the last thing is a neat little exercise. What do you want to do? It gives you a quadratic equation, but it has 2 unknowns. So it asks us to use the discriminant to determine the m value that will satisfy this. So if we want to have 2 equal roots, which means 1 real root, which means we need it to our discriminant equals 0. So plug in what we know. We know b is 4. We know it's -4. A is 3, and c is m. So we plug that in. We get -12m. We take the 12m to the right-hand side. We divide both sides by 12. And we get 16 to 12, which can be simplified down to 4/3. So if the m value or the c value or the y-intercept is 4/3, that will give us 1 real root. So again, I can confirm that on the formula. So if I put 4/3 in here, so that means I would have 3x squared plus 4x plus 4/3. And boom, lo and behold, it does give us 1 real root. That's sometimes, like I said, they'll call that 2 equal roots or 1 real root. We'll learn about that in pre-cal 12. It's called multiplicity, like I mentioned earlier. So no real roots, you would do the same thing in the B part, only this time if there's no real roots, it has to be less than. So that means if you pick any value, and I just rearrange, I solve for the same way as I did in A, and it says m is greater than 16 or 12, you'll have no real roots all the time. I can prove that. So that's around 1, that's equal to 1 decimal 3 repeated, right? So if I go to my function and I put in a value higher than this, so let's pick 2 to be easy, on our graph, it'll bring it up. So you keep bringing it up, and 5 keeps going up, right? 1 would come bring us down underneath, so therefore it doesn't count, right? Because remember, we said it's 4/3. Pretty interesting. So anything greater will go up. Well, there's 5, which makes sense because it's bringing it up, right? It's moving the y-intercept up, right? 6, there's 2, right? So pretty neat. And then the last one, it says mx squared minus 8x plus 3, two distinct roots, so that means that we need our discriminant to be greater than 0, so we plug it in. Negative 8 squared minus 4 times a times c is greater than 0. And when we work it out, we get an m value of less than 64/12, or 16/3 will always give us two real roots. So again, we plug that in our formula to prove that. And in doing so, we get, I'll just plug it in to show you. So we said our a value needs to be 16/3, or greater than 16/3. So I'll show you what happens when it's 16/3. A lot of you guys can probably predict what's going to happen. 16/3 minus 8x plus 3. There we go. So if it's equal to, right, one real root, and remember we want two distinct roots, and so every value less than that. So if we put 15/3, that would be less than 16/3, so that would be 5, right? So 15/3, which is 5, yeah, gives us two distinct roots. 14, yeah, oh yeah, it's just going to keep going down, right? Pretty neat. But when we get larger, then it's going to be above. So 17, right? 16 was our right on. 17 brings it up. 18, which is 3, which is 6, divided by 3. So pretty neat little exercise. I think it's pretty cool and worthwhile task to do that. So those homework questions are located on page 254, and it's number 1 and 2. And that's some more information on the quadratic formula. I want to further explore what happens when we have these negative square root, which is no real root. So I've added an additional section that's not in the textbook, but something I want to share with you that you can use in Pre-Cal 12 and calculus. And that's called, I think I might have mentioned in class, imaginary numbers, or what we call complex numbers, non-real solutions. So we'll see you again. I hope you're enjoying the videos, and we'll see you again soon in the next video when we do a section that's not in our book, but I think it's worthwhile. Everybody have a great day, and we'll see you again soon.